Okay, I don't want the timer to start until we know that my slides are not going to zip right through. Okay, here we go. So I've been sitting, no, that's a, right, okay. I've been sitting in the audience trying to think, okay, what's my hook? Why did someone ask me to be up here? Why do I belong in Bloom? Because this is about personal innovations and solutions to problems. And I want to say right up front that anything I talk about tonight is not just me personally. I've been fortunate to work with many, many wonderful people and groups. So if I say I, that's a mistake most of the time. And the other thing I want to say is, as far as I know, I have not solved this problem yet. But I'm working on it, and it's giving me great personal purpose. So I work for Washington Sea Grant, and I am their first ever ocean acidification specialist. They didn't know they needed one until I literally started working for free there and convinced them to hire me about a year later. So ocean acidification. I'm going to give you about 4 minutes, I hope, of background on what the problem is, and then I'm going to talk to you about me and other people's ideas for solutions. So this is the ocean. And it's really big. And a lot of people are like, the ocean, it's so big. How can we ever do anything to the ocean? Well, we already know that we are doing things to the atmosphere. So it's not really that surprising that you can affect the ocean. And this is a shocking slide I love to show people. If you took all the water on the planet, all the oceans, and you bundled it up into one drop, that's what it would be. So it covers about, I don't know, a quarter of North America. It's not that much. So what we actually have on our planet here is a very thin skin of water. And when you think about it that way, it's not that hard to believe that things that humans have been doing on this earth for about the last 150, 160 years are having a major impact on the chemistry of this little precious drop of water. So when I talk about what we've been doing, I'm talking about burning fossil fuels and also deforestation and really changing where the carbon on our planet is. It used to be buried underground. It took bazillions of years to get it all safely tucked away in there, and in the last 150 years, we've been doing our darndest to get it back up into the atmosphere. And when you think about it, it's no wonder that things are going wrong. That's really a very drastic and rapid shift for our planet. Okay, moving on. So what is ocean acidification? It is often called global warming's evil twin. It is the same root cause. It's too much carbon dioxide in our atmosphere released by the things that we like to do that make our lives very comfortable and enjoyable. A lot of that carbon dioxide goes up and stays in the atmosphere and is the basis for climate change. But about 25% of that carbon dioxide dissolves down into the water on our planet, into the ocean. And that's what's causing ocean acidification. So I'm going to give you a really quick, very colorful chemistry lesson here. You're going to love it. When you talk about acid, what is acid? What is acidification? Acidification is to become more acidic. This is the pH scale. If you read your shampoo bottle, you probably know about pH. It's just a measure of how acidic or basic a solution is. And it's a 14-point scale, and it goes from 0 to 14. And 0, the low end, that's the acidic end. And if you can read the red up there, battery acid is way close to 0. It's very acidic, very caustic. And then at the other end of the scale, way down here, sodium hydroxide, household bleach. That's the basic end of the scale. And right smack in the middle at absolute neutral is pure water. One very important thing to know about the pH scale is, like the Richter scale and the decibel scale, it's logarithmic. That means that 7 isn't just 1 less than 8. 7 is 10 times less than 8. And 6 is 10 times less than 7. So what appears, if I say there's a change of 0.1 pH units, that's actually a big change. It's not a little thing. It's 30%. And what I want to point out right here is that seawater is currently pH 8.1 because of all the salts and whatever that are in the ocean that are not in fresh water. Seawater is actually more basic than neutral water. but it's currently at pH 8.1. It used to be, 150 years ago, pH 8.2. We've had a 0.1 pH unit change in the pH of the ocean since we started burning fossil fuels. And this is why. Okay, so there's seawater, I've already told you. All that carbon dioxide that's dissolving into the oceans from the atmosphere, the molecule of carbon dioxide combines with the molecule of water and forms this molecule, carbonic acid. And that's it, that's the problem. You have a new molecule in the ocean that's forming, and it makes things shift towards the acidic end of the scale, and that's ocean acidification. So, in order to put this change thing into context for everyone here, I need you to do an experiment with me. Start holding your breath right now. And then raise your hand when you start to feel uncomfortable. And you can show off, you can try and go really far, but I know you're gonna give up, probably. All right, so the discomfort that some of you are starting to feel right now, that is not because you're out of oxygen. That is because carbon dioxide is building up in your blood. And look here how close blood is to seawater on this scale. We really do have the ocean in our veins. And the same change that's happening in the ocean now just happened in your body when you held your breath. Carbon dioxide built up because you weren't able to blow it out, and it changed the pH in your blood. Now, if your blood pH changes by 0.2 units, you go into a coma. And by the end of this century, at the rate that we're currently emitting carbon dioxide, our oceans will change by more than 0.2 pH units. Our oceans will go into a coma. Biology has evolved to live in a very narrow chemical, oh my gosh, band, and it's going to have a hard time coping. Now I'm running out of time, but I need to show you, this is the poster child of ocean acidification. This is a pteropod, and it's a snail whose foot has evolved into a wing. Are you going to hit the animation for me? Do I do that? Okay. And pteropods have shells, and does anybody remember what happens to shells which are made of calcium carbonate, which is chalk, when you put them in acid? They dissolve. So, whoops, yeah, whoa, going back. Okay, go ahead and mouse. All right. So this is a pteropod, and they're adorable. They're like little golden snitches, and they're all over. And they are a very important part of the food chain, and they are literally dissolving in the oceans. And the woman who can prove it is sitting right over there. I want you all to remember that you heard about pteropods first here because she's about to become very famous for her science, showing in about maybe a month, showing that pteropods are currently dissolving in the oceans under conditions that we find today. And there are lots of other animals in the ocean like pteropods. Anything with a shell or a hard part made out of calcium carbonate is going to be suffering from acidification. Now you know what these things are. We've got people food, we've got fish food, we've got other organisms here that are vital to our ecosystem. These guys right here make a lot of the oxygen that we breathe. The ocean plants make 70% of the oxygen that we breathe, and a lot of them are going to be directly impacted by ocean acidification. So we don't know what's going to happen in our oceans, but it's probably not going to stay the same, and I hope we don't continue this experiment. So to the personal part, I was lucky enough to have an epiphany about 2 or 3 years ago when I heard about ocean acidification, and I knew what I wanted to do. I knew that I wanted to tell other people about it so they cared, so that we could do something about it. And what my idea is, which I will talk to you about now, is to help other people replicate my experience. And I got this idea from Al Gore's Climate Reality Project. He has, his foundation has trained already 4,000 people around the world to become very sophisticated speakers about climate change. And their goal is to have these people speak to their own networks, their own communities, not preach to the choir. Everybody knows somebody who doesn't believe in climate change. If you get trained and supported to inform people about it, then you have an opportunity to change a lot of minds that otherwise probably wouldn't ever hear a convincing argument. And my idea is to replicate that for ocean acidification. It's something I hope to get off the ground here in Washington State this year with the support of a lot of other people and groups. And the reason I want to do this here in Washington State, and I want to talk to you about this afterwards, is that we're ground zero for ocean acidification in the world. There's a lot of factors, natural and human caused, that make it worse here than anywhere else. And it's already having a huge impact. So I hope that I've convinced you that it's a problem, and I would love to talk to anyone here who would like to find out more and find out how they can inform their own communities. Thank you. There.